Great. And I think along this two-edged sword that we just talked about in energy, Lawrence Berkeley Lab already talked about this tool being able to solve 90% of carbon emissions. And I encourage all of us to look into that a little bit more. And then speaking of meetings, that's happening every week on AI, another meeting that I have been to, and a shout out to NIST here. The whole framework called RMF, Risk Management Framework, is out for comments, and would just like to mention that it is another product that we can all visit and look at how we can be more able to create good learning models that are safe, secure, and transparent. So with that, I'm going to open up the next panel. Thank you, Fernando. We have two fantastic panels for you today. The first panel focusing on AI in design, construction, and project delivery. And then the second one will focus on building operations and renovation. We want to explore the whole AI ecosystem, or my AI colleagues call value chain, because our stakeholders are such a broad spectrum that include almost everyone in every discipline. So a little bit of housekeeping for those who just joined. We had mentioned that during the presentation, we would encourage you to ask short and concise questions. We will select those questions from the GBAC members first before picking those from the general audience, but we welcome all questions. So let me introduce this first panel. We have three experts from three distinct perspectives, and we will explore predictive solutions and scenario planning. We will also discuss risk mitigation and cost benefits in project delivery. So the first panelist, Stephen Hagan, CEO of Hagan Technologies, is a seasoned professional who understands public buildings. Steve is also a fellow FAIA who has spent his career at GSA on technology, working with BIM in public building services. And second, Sean Young from NVIDIA is a director for their AEC industry, and he has been working in this field for 25 years in 3D simulation and visualization, as well as leading go-to-market strategies. Last but not least, Virginia Senf from Autodesk. She's also a director for the AEC sector, working with companies to embark on their digital portfolio and unlock digital asset value. So these presentations will be augmented by use cases, which I hope you'll really enjoy, with an eye towards lessons learned and options for the future. So I will turn it over to you, Steve, to get started.
All right, good. All right, so thank you very much, Fernando and Joyce. And we forgot one who is our AI partner here that you'll be underlying a lot of our discussions today. But delighted to be here, and got a great panel that I'm excited to be part of. And you're correct that I have worked in the federal government, actually 37 years. I retired 12 years ago, not just at GSA, but several other agencies. And so I'm excited to share with you a couple of my experiences at GSA, and then tee up kind of an overlay of what Sean and Virginia will have as some more focus on the current technology. And I do have to have a shout out to GSA itself and Robin Carnahan, the GSA's administrator. Amount of work and leadership. She reports, at least may have grown since this last publication, over 150 pilots of AI throughout all the different use cases that they have at GSA. And very, very exciting to be part of this presentation today and your leadership. So we talk about GSA as the nation's landlord with 8,800 buildings and 370 million square feet. But in fact, there are more than 27 agencies that own, operate federal facilities. That's just a quick look at them from DoD, obviously much larger, Park Service, and the State Department's Overseas Building Office with all the embassies, and Veterans Affairs with hospitals and clinics. So, you know, from GSA's real property profile, 350,000 buildings, 2.8 billion square feet. So there's no question that this is a major force for both impact across the world and in particular the United States, and in almost every community, there's a federal building, federal facility that is there. And so no question that it has an impact on the environment. And in fact, you can see all the different reports that report on all that impact. And so one of the points I want to make is these reports all have different sources. And in fact, but we actually talked about this in your introductory presentation, but 1 to 2% of the total US energy consumption comes from federal buildings and facilities, and 40 to 45 million metric tons. And those are the sources of all that information. And then in order to look at that, see what that data is and see what we can do about it, there's a lot of data sources there that come in. And so that one could argue that that is just, again, a perfect example why we need AI to look across all of our portfolio and give us meaningful data about what we can take action on. So this is a diagram that I actually developed when we were at GSA. We were tracking both building information modeling and 3D modeling, but also all of the $12 billion of projects that GSA had in their pipeline. And one of the reasons for this diagram is that there is project delivery and operation and maintenance. Those are the two sessions today, but there's also something else before that called portfolio. And that organization and most other agencies will have a similar group like that. They look at their entire inventory of facilities. They look at the condition of them, their performance as a business model, and then they define what it needs to come into project delivery. Repair and alterations, need to dispose of some, need to create brand new projects. And then it frustrates a lot of people to find out how long it takes for us to do things. In this case, it was about 8 years from beginning to end, from approval to finish and hand over to facility management and operations for us to do projects. And there's a lot of little pieces that go with it. But that's the point, that we would like to improve this process, but also it's just the way things work. It's the way the process, and it takes some time to do things. And these projects are really amazing projects if you look across the portfolio. So one of the things that just came out, just recently published, is P100, the Facility Standards for the Public Building Service. And it's a document that's big and has a lot of its criteria and is referenced in every design and construction contract. And it must be followed for all these projects, but it really sets in place quality control, consistency, and standards. So, and around that is a whole body of knowledge and training facilities, et cetera, that work on that P100. But the question becomes, from a life cycle of a project that we showed earlier, from very beginning planning through design and construction, how does that interact with P100? And the way it interacts, where it could interact, is that we actually have digital buildings, digital projects underway, models that then check themselves or are checked against our standards to make sure that we are in compliance. And the promise of that is mentioned in the previous presentation. There's a whole slew of different ideas, and you highlighted those earlier, Joyce and Fernando. But the peril, and I guess maybe it's not peril, it's more challenge we have, at least in this McKinsey Global Studies report, is that we are, as an industry, at the lowest level of all industries in terms of being digital. So we do a lot of things with very expensive and powerful tools, and we do them in analog ways. And I think some of the presentations by Virginia will show very clearly as we do handoffs that the manual handoffs are continue to be very manual in process, and we need to move from that process to really a digital and connected way. So this is one of the presentations that kind of got me rolling on AI with my colleague Kimono Numa at the AIA Japan a year ago, but it was again looking at a vacant site in Tokyo and looking at all the possibilities of what AI tools could do if you became digital from beginning to end. And it's a very powerful idea of lots of visualization, lots of analysis of data. So one thing I would encourage everyone to look at, we have a flipboard that captures a lot of stuff that we find everywhere, puts it in there. Flipboard is a great way to have, as you can see, little nuggets of information. And these are just a few of the selected articles that come up across art, AI and architecture. AI takes digital twins from 3D to 4D. And everyone could participate in that and contribute to that. Before I complete this and hand it over to Sean, I don't want any of us to forget the power, I think, and it's really been GSA's leadership in terms of design and construction excellence, focusing on not just the analytical, but really projects that delight all of the users and all of the public. So with that, and I do think AI has already proven itself in many respects with that. So with that, I'm delighted to hand this over to Sean. And Sean, take us through NVIDIA's presentation. Thank you very much.
Yeah, thanks, Stephen. Yeah, next slide, please. Hi, everybody. I'm the AEC guy at NVIDIA, and looking forward to talking to you. I want to build on some of the concepts that were presented by the other speakers, and especially going back to what Zach said at the beginning, that there's some fundamental AI concepts that you should know, and I want to establish those in my 12 minutes that I have with you today. So next slide, please. And the way I think about AI with respect to AEC is, I think the analogy is this plant that even when you come back from vacation, you've left it for a couple of weeks, it's totally dried out, and you have the water pitcher, and the water goes everywhere. That's what's going to happen with AI and AEC. A lot of these examples Joyce, Stephen, Fernando have brought out this morning, and just any possible redundancy, painful manual process is going to be resolved by AI, not taking away jobs, but by augmenting and enhancing our productivity. Next slide, please. And I think what this means is that we need to be very conscious about, number one, understanding AI and adopting AI skills and knowledge ourselves, at the very least, so we can hire the right people to do the AI work. Because AI is going to come from two places. It's going to come from the software that you're using today. It's just going to evolve. Like your software evolved from 2D to 3D to BIM, it's going to now be like AI injected BIM, and Autodesk will talk more about that. But AI also is going to come from within your organizations, and there's some AI work that you're going to want to do yourselves to deliver services to your constituents and to augment your own pipelines across these three functions. So as the previous speakers mentioned, like in design, for example, I don't think that in the future we're going to be designing, doing BIM with our mouse. I think we're going to be typing, and we're going to be typing things like, here's the square footage, here's the energy requirements, here's the utility requirements, et cetera, et cetera. Here's the building codes. And AI is going to, just like computational geometry figured out shapes, AI is going to figure out the best way to use the space. So we're starting to see a lot of that innovation today, but we're in the very, very early days. Over in construction, I think AI is going to have a profound impact for you as the building owners and operators in terms of making sure that the construction project is proceeding according to plan, in terms of scheduling, in terms of cost, also in terms of safety. And there's so much data we can gather on a daily basis about the construction site by doing, like, for example, drone passes and doing photogrammetry. We're even injecting AI into that process with NERF and Gaussian splats, and I'll talk about that. But what do you do with all that data, like 3D data or point clouds? It's onerous for a person to evaluate this massive point cloud on a daily basis to try to find this very small thing. But an AI doesn't mind doing that. And an AI can do like progression analysis, change detection, predictive maintenance on all the equipment on the site. It could check for clashes. It can check the point cloud against the BIM to make sure that the construction is proceeding correctly. It could do safety full time for all the employees on the construction site. Similarly, over in the operations side, there's so much that AI can do and is already doing. And NVIDIA has a platform for operational AI in facilities called Metropolis. And it's basically computer vision-based AI, cameras monitoring a site and multiple cameras working together to predict what's going to happen based on what it sees. And this has a profound impact on safety, security, operational efficiency, energy, etc. One of the previous speakers mentioned like adjusting the HVAC or the lighting based on building occupancy. That's a great example. Another example is opening out like security lanes in an airport based on like, is the lineup too big? Another example is identifying potential security issues based on the gestures, based on the characteristics of the way a person moves, their facial expression, if a crowd is gathering. We could do all of these things today with AI, and I'll talk about NVIDIA's platform for that. Next slide, please. Here's some examples of the way AI is being used in practice. So this example extends from design all the way out to operations of the stadium. And in this case, Populous, the designer of the Sphere in Las Vegas, is also designing other stadiums, multi-use stadiums. And they want to predict not only the line of sight that every user and every seat has, not just one sporting type of event, but multiple events, a soccer game, a concert, a basketball game where the seating configuration can change. But they also want to predict, for example, neck strain of the person in the seat, the ergonomics, and also potential revenue, like proximity of the location of the concessions to the user and making sure those are in the right places. They can do all of this with AI. And then as the building this is in the design phase, but as the building is built and operational, that sort of digital twin AI model lives on to continue to refine and enhance the customer experience in the building. Next slide, please. Here's another example of AI, and this is used for both planning and for operations, and this is flood prediction, and this is from Stantec, where they're using AI to predict the potential flooding, and you could predict flooding based on weather data and historical data, but more importantly, what could happen and what's the evacuation, what are the evacuation routes, what kind of damage could we expect, etc. And this is done with AI. It could be done computationally, but it's also done more efficiently with AI. Next slide, please. And I talked about this before, photogrammetry and taking lots of photos of the site. You could use a drone, you can use terrestrial cameras, you can also use LiDAR, but AI can make this process much more efficient. By filling in gaps, by creating much higher 3D models, we basically train an AI to rebuild the scene and create intermediary images that may not have been captured from the source, to create a high resolution 3D tiled scene, which is basically the first input into a digital twin, along with your BIM data and other IoT data that forms a digital twin. Next slide, please. So these are some examples of what some of our partners are doing and some of our customers are doing, but what's really important for you is to think about all the decades of data that you have in residence in your hard drives. And how do you turn that into intelligence? And manufacturing intelligence is really what NVIDIA does and what AI does. By the way, I should mention that, and I should have mentioned on the previous slide, NVIDIA, we don't deliver software for you to use out of the box. That's the job of our partners like Autodesk. We deliver developer tools. We have a lot of software at NVIDIA, and that software is really developer tools for your AI software and data science software developers on your teams to use to write your own AI, and for our partners like Autodesk to build their AI, and ultimately deploy that AI on NVIDIA computational infrastructure. So I think it's really important for you to understand how to leverage your data, because with that data, there's so much you can do that will improve your processes. Next slide, please. So I want to give you a little bit of a primer on using your data to train an AI. Now you can create your own model. There's a lot, you've heard of AI foundational models, and there's a whole bunch of community models and private models out there. If you wanted to create your own model, it takes a lot of data. For example, like OpenAI was trained on all the data on the internet. An image-based model that is able to create or recognize images like Stable Diffusion could be trained on like 500 million images. The way training works is you feed the AI, for example, cat and dog images, and every time it recognizes a cat, you reward it. Every time it thinks a dog is a cat, you punish it, and it eventually learns. Next, that takes a lot of computation and training time. The next iteration of that is to start with an existing model and fine-tune it based on a much smaller set of data. So it could be thousands of images instead of 500 million images. So for example, you start with an image library, an image foundation model, and you train it to build create generatively a certain type of building. That's fine-tuning. Next slide, please. Where I think you're going to get a lot of benefit is retrieval augmented generation, or RAG. And in this case, you don't have to build any model at all. You can use a model and you do not have to fine tune. And basically what RAG does is it takes a model and connects it to a database. And so you can do like a real-time, avoid any hallucinations, a lookup of data. And let me give you a couple examples. Next slide, please. In this example, AECOM is basically chatting with RFPs that come in. So they can summarize the RFP, they can extract data of an RFP. Now they're using a large language model, like a basic community model. With RAG, the RAG is going into the specific RFP and using the data from the RFP to bring the right responses back from the user. So like how many windows are in this project? It will give you that response. And using that data, you can also form a response back to the RFP in terms of a bid that references AECOM specific pricing, contractor, et cetera data. Next slide, please. Here's, as Stephen mentioned, compliance. Now here's a great example of a code compliance RAG, which is checking the building design against a local building code, in this case it's Australia, and making sure that the BIM is compliant with the code. And again, there's two sources of data. There's the BIM itself and there's the code itself. The code is very specific and can be updated all the time. Next slide, please. You can actually get started with this very easily using NVIDIA Chat RTX. And what this does is it creates a RAG database from files on your desktop. So you can upload a couple of PDFs there, for example, on the P100 specification, and you can now chat with the specification. Imagine that. You can learn all about it by asking it specific questions, by building a RAG. There's not much to it. There's the information. You just need the right NVIDIA GPU with, and the technical requirements are on that website. Next slide, please. I wanted to talk to you finally. I mentioned NVIDIA has a platform for operational vision-based AI, or compute vision, and this is called Metropolis. And there's a number of elements to it, and Joyce mentioned inference. The first thing is inference, because if you want to deploy AI for operations to a constituency of a lot of users, they're consuming that AI in inference time. All those cameras are operating on the inference level. You have to make sure you have the right infrastructure. NVIDIA NIM has that infrastructure for you. Then you have to do some things in advance to deploy that AI. You have to train the AI. And you want to train the AI likely in a synthetic environment, because for example, if you want to train the AI to recognize aggressive people or crowds, it's very difficult to do that in the real world, or train it to recognize car accidents. It's difficult to do that in the real world. That's why we have a platform called Omniverse to simulate the physics of the real world in the synthetic environment. So you could simulate characters attacking something, and now you've trained an AI to identify characters that are about to attack. And then there's the infrastructure required for the edge. I'm happy to talk more about this at a future time. Next slide, please. You could also learn all about these AI solutions that we have and even experiment yourself at build.nvidia.com. It's free to use. You can grab the code. You can run these inference executions of the AI on our own servers at our cost. So feel free to play around and learn. This is the best place to learn. And all of this is based on NIMS, which is optimized inference running on NVIDIA GPUs anywhere. This particular NIM, these NIMs are running on the cloud, and that's my time. Thank you. That's my email. I'm happy to answer questions by email and chat with you all more anytime about any of these topics.
Hey everyone, I'm gonna jump right in here, given I've been warned we have limited time, and I have a lot of content to touch on today with you. Really excited to be here, and what I'm gonna focus on is the role of AI more in the beginning of the design process today. I'm Virginia Senf, and I lead our data strategy for the AECO industry at Autodesk. I'll use AECO, short for, I think we've used it already today, architecture, engineering, construction, and operations a lot. So bear with me on the acronym front. If you don't know Autodesk well, and you can jump to the next slide. Next one, sorry. If you don't know Autodesk well, we are a design and make software company, and in the last 42 years, we've led several digital transformations in the AECO space. The first one was the move from hand drafting to electronic drawings with CAD and AutoCAD back in the 1980s. The second one was about 22 years ago with the introduction of building information modeling, or as we call it, BIM, as we launched Revit and moved the industry from 2D to 3D modeling. So if you think about it, really anything that's designed or built most likely has had a helping hand from one of our products. Most recently, we've been selected as the design and make partner for the LA28 Olympics, a project we're especially excited about given their sustainability goals for the Games. Next. To give you a quick sense, if you're not familiar with it, of what building information management enables, here's an example of BIM used to design the complex underground system for the Grand Paris Express. All 68 new stations and 200 kilometers of new line was delivered using BIM. Being able to model the design digitally delivers a significant advantage considering the complexity of the underground system, and it resulted in being able to measurably reduce the impact to the existing transportation system. As you can see, BIM has enabled a new level of accuracy when it comes to designing and maintaining a digital twin of a built asset. Next slide, please. However, that level of detail has also created an enormous amount of data. As you're already well aware, and we've touched on so far already today, every industry in the world is dealing with more tools and data than ever before. And within the AECO industry specifically, this problem's been especially acute. In fact, it's estimated that 95% of the data that we generate goes unused at an annual cost of almost $2 trillion in poor decision making. Yes, bad data is costing us almost $2 trillion a year. So to put it simply, the industry is drowning in data, and frustrating, it's still largely an untapped resource. Next slide. Here's another view of the problem, looking at today's processes. The amount of data associated with a specific project obviously increases as the project progresses, But today what we see is every single time an information handover occurs between teams or across phases, data loss leads to inefficiency and risk, and that ultimately impacts budget and timeline. Next slide, please. At Autodesk, our vision has always been to bring those disconnected stakeholders together and support a full unified digital asset lifecycle project from the design all the way through operations. Next slide. So the question around, next slide, sorry. So the question around how do we finally connect all those stakeholders and start to realize more value from all that underutilized data? We believe the answer is AI, which will power something that we're calling an outcome-based approach and enable new ways of working. What do we mean by outcome-based? I'm going to spend a few minutes here. This is a new paradigm that puts the outcomes of a project at the center of the design process, improving on the current approach where we design first and analyze second. With an outcome-based approach, we start with data and we leverage AI to generate the best options for the project at the beginning of the project lifecycle. This will allow organizations like GSA to consider trade-offs and make decisions earlier in the process based on whichever project constraints are most important to you. And that ultimately allows you to drive better productivity throughout the asset lifecycle. So imagine in the future, you'll start by defining the desired outcomes for the project. For instance, on a retrofit, it might be what's the maximum cost? Are there any sustainability requirements or environmental considerations that need to be taken into account? Maybe what's the preferred method of construction? And from there, AI will explore a broad range of options within those constraints and guide you in choosing the best option for each project, allowing you to explore many more options than you would have been able to without AI. Next slide, please. So you might be wondering why start at the beginning? And to help answer that, I want to introduce a framework called the McLeamy curve, which was developed by Patrick McLeamy, a former CEO of HOK, a large architectural design firm. The basic premise of the curve is that the cost of design changes goes up as you move through the asset lifecycle, while the ability to impact the cost goes down. In other words, if you invest more effort in the early design stages of a project, you can have a significantly higher chance of impacting cost and reducing errors during construction and even into operations. That pretty much seems like common sense, right? Do the analysis before you start building so that you don't have to make changes once the building is already partially or fully built. And what I want to highlight here is that while this, when it was created, focused on cost, it really applies to other constraints like sustainability outcomes as well. Now, thinking back to the sawtooth curve of data loss that I touched on, we typically have the least information when we start a project. Or do we? Next slide here. Building on what Sean shared, I want to say that the good news in terms of where we are with AI today is that many of the existing applications help you start to benefit from AI without having your internal historical data sets, needing to have your internal historical data sets ready to train on. So here I'm just going to look at a quick example of how AI can help us fill in data gaps at the early stage of the project, specifically here through an embodied carbon extension that our Forma product delivers. Next slide. The data model that powers our embodied carbon extension is provided by a third party called C-Scale. And it's built on a mix of both synthetic data that they've created and then data from existing projects that they've structured and prepared for the model to train on. In short, they've done the hard work of structuring and validating the data so you can benefit from the insights without actually having to bring your own historical project data to the table. Next slide. And this enables really accurate real-time analysis for early stage designs. Next slide. We'll then, of course, see continuous optimization of the model as more and more project inputs are run through it. But beyond that, what about being able to realize more value from the vast data set available to you and your colleagues at the GSA? Leveraging existing AI models is a great place to start, but there's also enormous potential in being able to leverage your own historical data to establish a more accurate, tailored version of AI. We know that making your data more usable, structured, and consistent is one of the biggest challenges that you're facing today, and you're definitely not alone there. This is a quote from one of our customers in our annual Design and Make report. Next slide. And what I want to highlight is that AI's promise really lies in being able to finally realize value from all that underutilized data that we've been creating, throwing away, recreating, not being able to share with stakeholders. AI is really going to give you the ability to learn from your existing built assets and past projects. And at Autodesk, given our unique perspective in the industry, we frequently get requests for best practices. So what's the best way to be designing, delivering, and maintaining built assets? True insight is derived from being able to analyze that huge reserve of existing data that has thus far remained untapped due to its unstructured and inaccessible nature. Next slide. Once we're able to structure and connect the data, you'll then be able to take full advantage of learning from the cross-project analysis that AI enables. So what went on in your best projects? How can you achieve maximum sustainability in a retrofit? What should you avoid and learn from on projects that were over budget and behind schedule? All of those insights will be delivered automatically. Next slide. That all sounds great, right? And I think Sean's touched a little bit on that potential as well. But oftentimes when we talk to our customers, you start seeing this worried look in their face, and you might already be thinking about the quality of your data. This is a critical aspect to consider as you establish your AI strategy, that the reality that the accuracy of AI is dependent not just on the quantity of data it's fed with, but also the quality of that data. We frequently talk about the vast amount of data needed to train large language models. However, it's equally important to note that AI is only as accurate as the data it's trained on. And in our industry, today, so many of our quality assurance workflows are still relatively immature and frequently executed on a manual basis. Let me give you a quick example of this that I recently heard from one of our customers. They started analyzing models across 300 projects and discovered frequently that specific assets had upwards of 10 unique naming conventions. So if I give you an example, on a hospital project, a nursing station might have been nurses station somewhere, nursing station somewhere else. And this opportunity is where GSA is uniquely positioned to benefit from AI. You guys obviously have access to one of the largest portfolio of assets and data in the world. So that quantity of valuable training data for AI is not an issue. And we know from our work with you at Autodesk that you've also been investing heavily over the past few years on establishing clear BIM standards, which are the perfect foundation to enforce structure across that data to ensure its quality in addition to the quantity. Next slide, please. And I like to talk a little bit about why this matters, right? We've all heard about the fake legal cases and hallucinations, but our industry faces much more serious risks if we train AI on bad data. A stairway to nowhere here is kind of a funny example, but think about an incorrectly calculated foundation or a retrofitted building that doesn't meet today's codes. Next slide. Once your data is structured, you can then begin to leverage it to fuel AI applications. And at Autodesk, we believe, similarly to what the other panelists have shared, that AI is going to be a co-creation partner. It's not going to replace humans. It's going to help automate tedious tasks, augment human creativity, and then analyze the data to provide critical insights. I'll finish up here by giving 2 examples of what outcome-based design in the real world looks like. Next slide, please. Here's an example of a project that we supported in Oakland, California. As you know, lack of affordable housing stock is a challenge in many places, especially so in the Bay Area. And to address that severe housing shortfall, a team of developers and architects is using modular techniques to build efficiently and sustainably. You can see here an aerial view of the project's parcel of land. Next slide. And on the spider web diagram up in the middle left, there were specific desired outcomes marked for this law, which included factors like cost, the embodied carbon, and diversity of room types. Using AI, the project team was able to explore the different configurations. And as they did that, they were able to see the trade-offs of those outcomes. So think back to that McLeany curve. Then, next slide, they were able to outline all the different modules that would fit onto that site. And with the help of AI again, understand the different configurations possible for the different buildings, looking to maximize the amount of living space. Next slide. Combining the building configurations and the building layout together, the team identified the best set of options for the project's unique target outcomes. And this is really a great example of how AI helps augment our creativity and ultimately enabled beautiful, affordable homes to be designed and built both quickly and sustainably. Next slide. Finally, here's an example of how AI powers outcome-based automation. As you know, construction projects like hospitals and schools are very repetitive and can be scaled similar to a manufacturing product. Architects, of course, tend to like uniqueness, and they generally don't love thinking about repetitive patterns. So what we did here was collaborated with our customers to find a way to conduct post-processing analysis of architectural design. The example you see here is of a hospital in Northern Europe. We analyzed all the different rooms and searched for common patterns. And in this case, we found 20 or 30 different types of rooms. Next slide. Once we identified the room types, we looked at ways to reduce the number of room patterns by adjusting the design slightly to get down to just 5 or 6 patterns. And when we were able to limit it to those patterns, it suddenly became much easier and faster to automate fabrication and create repeatable processes, which meant that the hospital was much faster, cheaper, and sustainable to build. So as I wrap up, next slide, hopefully I've introduced some of the powerful analysis tools already available to help you start making decisions earlier on in the project lifecycle. And the opportunity that both Sean and I have highlighted is that supplementing those generic models with your unique data sets can make AI even more powerful. But remember, it all starts with the important yet hard work of getting your data structured. So I think for you all at the GSA, investing in applying and validating your BIM standards today so that you have a strong foundation of a large quantity of quality data to build on as you move up this hierarchy of needs to data intelligence will be really important. Thank you.
Wow, thank you to all of our panelists. These are stunning, great slides that I think we'll learn from years to come. But it is really an opening into a topic that I think we all want to embrace in the future. I have a couple of questions for the panelists, but I do see some chats already happening. And I like to address that because I think bias and equity are really top of mind for many of us who really like to take it to the next step and understand this a little bit more. Myself, as a commissioner of environmental justice in my local city of Philadelphia, we hear that a lot about how AI is going to be equitable. So I like to kind of post that to the panelists and also kind of, take it a step to see how we can do that, with bricks and mortars, because that's a lot of what we deal with. I do know that there are a lot of questions out there with facial recognition and the like, but what I see as opportunities are applying that to affordable projects. I think we saw an example just now. Imagine all the low resource projects that don't currently have access to high quality, resource intensive analysis. Sean had also pointed out some example of resiliency. So I hope that maybe you can all address that a little bit of how we can push that envelope to make sure that equity and inclusivity is addressed in these high-tech scenarios.
Yeah, Joyce, I could speak to it from a technical perspective, and the way I think about it is, and it's really what Virginia was emphasizing, is garbage in, garbage out. AI doesn't know anything. When it's born, it has to be trained. So you have to make sure to train AI on good data. If your data has disinformation or misinformation in it, the AI is going to pick that up and think it's the truth. So there's a very important practice, and I really didn't get into this in my presentation due to time constraints, and it's called data science. The data science can be applied in your BIM methodology, and that kind of provides the constraints and the schema for the way you standardize your BIM. There's other types of data science that can be applied to other types of data, your Excel data, your text data, whatever that is. NVIDIA has a number of tools for data science, but before you do anything with AI, you have to make sure the data is ready, labeled correctly, and it is what you want. And that discipline is called data science, and NVIDIA is happy to help you with that.
Steve or Virginia, do you have any comments? And I think that was a question about cost. If you overlay AI to an affordable housing project, do you have any information of how we can do that affordably, Virginia?
Yes, I will highlight that cost is definitely one of, as you can imagine, the outcomes or inputs our customers are most focused on. And I think I also saw a question, I think, around how can AI start to take into account outcomes such as the impact on the existing residents or kind of environmental impact. And it's really about understanding what outcome is a priority, right? Like maybe you could spend, I don't know, $100 million and have the perfect building that wouldn't impact anyone in the neighborhood, but your budget might be 10 million. So you might have to make some trade-offs there. So that is something as we're building out our AI offering that is enabled by outcome-based design. It's the ability to kind of have that spider web where you've got 8 or 9 different outcomes that you're tracking, and it's really up to you then to decide with the help of AI, right? Obviously analyzing hundreds of thousands of different designs, which one fits your unique use case.
Yeah, and I think both Virginia and Sean had some great points. I guess I would say one term we really didn't talk about was prompt engineering. And the question is, what problem are we trying to solve when you talk about outcomes? Really think clearly about what those outcomes are. And the question that then you ask the data is going to influence what answers we get and what we can do from there. And I think there's maybe Sean or Virginia can reply to this, but we have a prompt engineer, and then we have a dialogue that starts happening with the results that you get back from the data and from the AI.
Yeah, and you could add to that, Stephen, guardrails. So in the process of inference, and that's deploying your AI to your constituency, you can establish guardrails so that the AI inference process can look out for misinformation that is coming back into the responses. And certainly like prompt engineering and restrictions on the prompts instead of free form typing, there could be some UI to drag and drop things, for example. And I'm sure you're going to see things like this from Autodesk in the future. That helps to get you a more tailored response. But also, as I mentioned, RAG, retrieval augmented generation, will ensure that the responses are verified with real data and not hallucinated.
And adding on to that, I think one of the questions that been posed in the circularity of building, I believe, Virginia, your example already pointed to some of that evaluation taking place in AI in real time for an affordable housing project. Do you want to elaborate on that? I think biodiversity protection and indoor air quality, those kinds of things in addition to your carbon calculations.
Yes, 100%. And I believe, Joyce, you shared a link to the project earlier in the chat that was called Project Phoenix. It's a really interesting project because it's actually a company that they're basically developing wall materials out of a type of organic mushroom compounds. So they're very environmentally friendly. And the benefit of outcome-based design, right, is that you're going to be able to design to certain outcomes or goals at the beginning, but then actually as you move into the operations phase, and this is why for us it's so important that we're really partnering with our customers across the full life cycle, is then to go and verify, right? Like, okay, we said the cost was going to be this, and we said that it was going to be these sustainability requirements. Did it actually do that? And based on being able to feed kind of the reality and how the outcomes turned out in the real world back into that model is only going to continue to increase the quality of that input. And obviously, I think as you get into the next panel here, and we've already touched on some of these use cases about what's possible in terms of, monitoring the building once it's actually a built asset. Again, all of that data can be building back. And we even think about this in terms of building products, right? All of these manufacturers will say, hey, spend more money on our product, it's less likely to break, we have a longer warranty. Well, all right, did that actually meet the warranty? Did you end up having to go and replace it early? Really being able to monitor all of those costs throughout the full asset life cycle.
Great. I see that there is another question from the chat about gender equity and inclusivity. I think this is a good time to put it in front of all of us, in private businesses and public sector. How diverse is that? And if there are any particular programs or initiative that each of your companies are embarking on so that we can ensure the data quality, as you have all talked about?
Yeah, for sure. That's a great question. And I know for us, diversity and inclusivity is one of our core values at Autodesk. It's something that's really top of mind for us as a company around everything that we do, including AI. I think when it gets to the specific data and information that we're looking at, this is a question that I would say the industry as a whole is still working through and kind of figuring out, right? I want to be upfront there about where we are, but there's a lot of potential, especially as we get these initial tools and models out there to kind of, again, monitor how they're actually performing and what they're actually suggesting in real life. And I think that feedback is going to continue to help us improve the quality of the suggestions that our tools are making.
Outside of the technology that I mentioned before, to make sure that you have a data science approach to generating your AI, you have guardrails in place, you're using RAG, you have the right data. I think it has a lot to do with people. NVIDIA, I'll just tell you as an employee, is the most diverse company I've ever seen. It's incredible. And we're very proactive in diversity and inclusion in the way we do hiring. And I think that makes just like everything else. I mean, it makes a difference on to the user experience. It makes a difference to the data that we generate and to the results of our company.
Great. I see that there are some links being shared, and we know that Silicon Valley is transforming, and we hope that with the EO and all of the public policies, not only federal government, state government pushing for that it is transforming for good. Steve, do you have a thought on that? You're mute. Steve, you're mute.
I'm mute. I agree with both Virginia and Sean on this.
Well, great. I think along the same lines, I had a question about now with the, I guess, charge that the government has given through their EO. Really, how do we build responsibly with the current portfolio information that you all now know? Are there opportunities to begin to think about a small pilot project or a training model, a foundation model within this portfolio that you could foresee as a first start so that this particular iteration can begin to inform future projects? Someone mentioned P100 as an
Yeah,
example,
oh, yeah,
but
yeah.
it's deal with such a huge amount of projects. Where is a good place to start, for example?
Well,
I think that's a good.
go ahead,
Go ahead,
Stephen.
Sean.
No, you go ahead.
No.
Yeah.
Well, I was just going to say, I think we've got a slew of projects at various stages. I think you really need to start with ones that are in the formulation stage today, and every one of the 11 regions of the Public Building Service all have people that are really excited about, piloting. So I think getting pilots and getting advocates in those regions to work on it would be great. I think that's the key thing, is to just go ahead and do it and see what happens. Go ahead, Sean. I'm sorry.
Yeah, I'm just going to go back to the example that I put in my presentation. I mean, everybody needs to learn about P100. So here's a great opportunity to experiment with AI. Do a RAG on retrieval augmented generation to chat with P100. You could do this yourself in like 5 minutes. Just download the chat RTX. I can repost the link in the chat if you want. And
Please do.
start chatting with your P100 documentation.
And Virginia, based on what you learned from the housing project, is there anything relating to, let's say, office buildings, courthouses, other, regularly seen public building types that you can translate to?
Yeah, that's a great question. I think what we're really seeing is that when we look at different types of buildings, right? Like each building type, whether it's a hospital, for example, or a courthouse or an office building, they're unique in their own way, but then the patterns within those specific building types are quite repeatable. So the hospital example for, taking that, we obviously ran the analysis on a hospital, but that could easily be run on an office building as well, right? To see those similar layouts and room patterns that we could then apply in a more programmatic way to ensure that it's easy to actually manufacture and build and get everything on site. So we see a lot of potential, I think, across building types. And the last thing I'll kind of mention there, going back to that question of the, how can you kind of like trust the data and make sure it's accurate? Another tool that we're seeing be really important to our customers, and I'm sure this is something that the tools that NVIDIA is providing deliver as well, is being able to, like, you get a suggestion, right? Or you get a summary, and being able to just go click on where that information came from, right? Whether it's in the model or in an RFP, so that great, it saved you time. But if you have any kind of like doubt about, hey, are you sure that's accurate? Did it pull it from the right place? You also have an ability to go and actually verify where that information came from.
Great, thank you. I'm so happy to see a GBAC questions from Ralph Denola. I think it's a very important questions because that's something that our advisory committee has been working on. Net zero energy and decarbonization. I had worked hard to look for some example. Number one was the Paris 2024 example, where they achieved 80% carbon reduction. And don't forget, they work very hard on their buildings, but they have some transportation issues to have to deal with. So it was not net zero. And in the case of the LBL study, there are opportunities to do 90%, which is still not net zero. But that's when I see in various government publications that a proportionate roadmap for AI is important. So maybe address Ralph's question. And also, if we don't get there tomorrow to net zero, but we want to get there as soon as possible, how do you see AI working on this proportionate roadmap? Any of you can jump in.
Yeah, I'll just add, I think, whether it's in the question or Joyce, and kind of how you set it up there, I think that word roadmap is really, really key, right? It's not like we're going to get to a point tomorrow where AI helps us get to net zero overnight. It is very much going to be a process. And I think we've all of us, all the panelists here have spoken to the fact that we see AI as something that's going to help augment our existing processes. And so the opportunity here is to look at the different teams that or disciplines that you have within the GSA and start to identify kind of those measurable or achievable improvements that you can make towards that net zero outcome by leveraging AI, and eventually build up to that goal. I think the idea of a roadmap is really critical.
Yeah, and I guess I would add, I always link up a roadmap with a strategic plan. What is the strategy, and what are the steps along the way? And one thing I would add to it, and one of the things we did originally with the BIM program at GSA and then at AIA Technology and Practice was, what about rewarding progress, awards program? And one of the things we did with BIM was, what projects could not have been achieved without AI? And so we start to look at things that are being done today, bring them forward and really celebrate those successes, and then build on top of that with a body of knowledge of success stories.
Yeah, and in terms of the technologies, I think, well, Virginia has a great demo showing Forma with the C-scale foundation model to predict energy outcomes. So, I mean, you're already seeing this type of technology being productized and available for you to try. That's the nice thing, because I think Virginia, like, there's a 30-day trial on Autodesk software. So you can go and start to play with this stuff right today. And see how it works for you. And very similar also for NERF. I mean, all retrofits start with scanning an interior, exterior scan of the as-built. And you could use AI to help you with that process in the form of NERF and Gaussian splatting. And I'm happy to provide more information on those things if anybody's interested.
And maybe this is a time to give a shout out to local government colleagues. Many cities, including New York City, have put in requirements or incentives for new buildings to be net zero. So right there and then, we're dealing with the AEC industry here. Can all new buildings using some of these products go to net zero on day one? And then this proportionate roadmap could begin to look at the rest of the portfolio and do it over time. I think that the follow-up question is anyone, GSA or outside, applying this to facilities capital planning? Do you see any of the clients or companies that you work with have already embedded this? Or if not, what may be the difficulty? Is it a reason for imperfect BIM modeling? You don't have enough of the data portfolio to really do capital planning with?
I can tell you for certain that NVIDIA has many US public sector customers using our AI solutions in building operations in the form of the Metropolis technology that I was talking about. So I don't have the specific examples off the top of my head. Rob and Rudy from NVIDIA may be on the call and can help me with that. But yeah, I mean, this is happening right now.
Yeah, and I'll just second that. I think the tool that I showed around at the beginning around the analysis we can run through Forma, that was actually originally largely leveraged by capital planners, and they obviously oftentimes work with design partners and architects on those. So we're really expanding access and use of the tool. But this is definitely being used in the capital planning process today.
And the next frontier, so I'll just plant a seed. The next frontier is digital twin. And Virginia mentioned digital twin in her presentation, and I mentioned it a little bit as well. And I think it's where all the data comes together. You can imagine having a digital twin of not just a building, but a city like Washington, D.C., where you could start planning for infrastructure. For one of the important themes is quality of use of a building in large spaces. In terms of and Joyce mentioned transportation, well, you have to consider transportation in the whole user experience and the cost. So having a digital twin to not only simulate a building or a space that's going to be built, but to continue to refine, iterate, monitor, and improve that space is really interesting frontier.
And Sean, I think your point is just perfect, because what about a digital twin of the portfolio of a company or organization or agency, where you can then start to look at how across a whole slew of buildings, how they're performing and what to do with that portfolio.
Good point. I am seeing that there is one more comment about federal government building data, having that confidentiality concern. I do know we are running out of time, but if you have one thought that you would like to share, I would just suggest that maybe we can also carry that into the second panel of that discussion, because I think it goes across from construction design to operations. Any one of you with a last word before we close out?
Yeah, really quick. There really isn't a restriction. You could run AI, you can do AI fine-tuning and AI inference on your Gov Cloud or on-prem. It's all possible, and we're happy to help you understand how.
Well, wonderful. On that note, I think the greatest news is that some of my questions didn't get answered because we have such an engaged audience. So I want to thank all of you panelists, as well as those in the audience who asked very good questions. And I would suggest that please engage with us. And I believe you all have Michael Bloom's email as well. Do get back to us. We want to talk some more. And this is the first of our attempts to get all of you engaged. So thank you. I'll turn over to the second panel.